Hello and welcome to the Elixir Roundtable. I'm El Imhoff, your host for today. Joining me is Brooklyn Myers.
Hello, very nice to meet you or be here. I'm a little jet lagged, everyone. So my apologies and appreciation for your patience.
And Brian.
Hey, everybody.
Mike.
Hi.
Adam. Ryan.
Hello.
And Andrew.
Howdy.
Our topic for today is LiveView Native, which Brian announced at a keynote at ElixirConf 2022 here in the United States. Brian, tell us all about it.
All right, so the video is released now, the ElixirConf keynote, and I'm going to try to not just repeat what I discussed in the keynote so that this is a bit maybe deeper and provide some Dockyarders some opportunities for questions because, I think most people at Dockyard knew this project was going on. I think many of the engineers are probably not as familiar with it as others within the company. So we've given our own engineers some early access to things, but they're very good workers. There's some of them are doing client projects instead, which is totally fine. But there's lots of opportunity for us to shape what this becomes right now. While what has been done to date is essentially beyond proof of concept, and we're past that point, we've been able to show that this is viable and you can build actual applications with it. We have a lot of work ahead of ourselves in terms of how do we shape the API, what features are we punting on, what features are we incorporating, and how best to get it into a stable position that companies will want to bet on this technology. And how do we best set up other potential native clients for success? So a bit of background, if you're having to be watching this and you're completely unaware of what LiveView Native is. So LiveView being the essentially server-side, client-side framework, if that makes sense, for Phoenix, there was really nothing special about it for the web other than it was using a library or is using a library called MorphDOM that allows it to very quickly patch in DOM diffs that are coming over a WebSocket connection. And the real magic around LiveView is in the server-side programming model. So we can subscribe to events from the client side. We can push new events from the server side that get merged into the client side. We can very quickly and easily build up what otherwise was very complex client side interactions now with the server side. Server side developer ergonomics, more or less. And in many ways, this is a return back to a time before the heavy client-side frameworks, but now done in a way that doesn't get out of control. So LiveView has struck a really good balance between what functionality you can build out, what complex functionality you can build out in the client, but done in a way that makes it very fast and easy to build out reliable, viable applications with, as opposed to, and I can speak to this point with some level of expertise, going the full client side, full JavaScript client side route was a significant cost in terms of build time. And if you happen to find a bug, goodbye week. I mean, it was having to really dive down into the bowels of a very complex and large JavaScript libraries is extremely time consuming. Whereas as we've seen with Elixir and functional programming, it's pretty easy to identify and fix bugs that may pop up that you see. So anyway, on to LiveView Native. So LiveView Native was born from this idea that because the DOM is composable and the Morph DOM library is relying upon that in a way to patch and stitch together the new DOM updates. If we had a corresponding UI framework on mobile that was composable, then we potentially had a path forward to doing to modifying LiveView in a way that worked for native. And the obvious kind of competitor in this space is React Native. And this, in many ways, has influenced Dockyard's decision to put dollars behind this technology, behind LiveView Native. We've seen over the years that React is starting to really eat up the ecosystem because it has done a good job at adding additional capabilities under its namesake. So you first start with React.js, which is the web client-side framework. Although framework is a loose term in the React space, I'd say that there are ways to build a framework with React, but it's really, I'd say, more heavily favored on the render side. But some good people have put together a lot of libraries to bring that together. I think now there is actually React app, if I'm remembering the names correctly, and this is essentially a way to generate a idiomatic, or what the community has been gravitating towards, idiomatic React apps. So then came React Native. And so at that point, well, maybe a year after, because those of us that remember when React Native launched, there were all sorts of bugs. But you had a situation now where companies were looking at React favorably because it allowed them to transition their front-end web developers over to front-end native side application developers. And maybe 6 months ago, maybe a year ago, I forget, time's all melting together for me now, but there was a React server-side framework that was launched by Ryan Florence, who built React Router. So at this point, React has a good reason to stay on the full stack as a company, meaning that if you go with React, then your overhead on your talent in your engineering team is going to be significantly reduced, because now you can, based upon needs, have your React web developers move over to server side, move over to native. And while not every single problem translates over very well from a client application to a server side app, there are definitely different knowledge domains there. You can imagine how much easier it is for a React engineer to move over from React client side to a React-based server-side framework. There are going to be conventions, there are going to be certain project structures and such that just translate over, and their ability to be effective should be obvious. So all this to say, over the years, we've seen at Dockyard multiple clients come in asking for React on the front end. And we've responded by adding a React developer now and then, because we shouldn't be turning away projects just because of React. But at the same time, we're seeing the encroachment that exists there, right? There are companies that are well aligned and would highly benefit from the technological advantage that LiveView would bring, and using Phoenix in the way it's meant to be used, not necessarily as an API, but as in the way that LiveView's using it. So we're handling reconnects, we're handling uptime, we're handling all these nice things that come with Phoenix, and you're getting those advantages on the client side. But convincing those companies to go with LiveView is impossible, because they say, no, we want native and we want web, and we have a team for that already, or we're working with this other consultancy that does that. And that is a huge cost savings. So this got us thinking at least a little bit. And then some other projects that came Dockyard's way, internal projects that we actually were building out some native applications with. We experimented a little bit with Swift UI, and it was the spark of the idea that this was possible was born from that. About 2 years ago, well, probably spring, that 2.5 years ago now, Chris McCord and I started punting around the idea of whether or not this was even possible. there was some proof of concepts done with a protocol in Swift called Codable that allows you to take one format and basically convert it automatically over to some type of data within Swift. In this case, it was outputting Swift UI components and taking a JSON document. And then this prototype was updating the JSON document key value pairs. And you'd see the actual UI on device update in real time. And this was like, oh, that's actually pretty cool. But JSON as the document system was far apart from the markup style that at the time Leaks was in Phoenix was using, which eventually moved over to Heeks. And so some more time was spent looking into this. We found an XML codable library, but it wasn't working the way that I was hoping it would work. I reached out to the developer of it, and his suggestion was that his name is Max Desiatov. I spoke about him at ElixirConf, and since then, which is literally a week and 1 day ago, I've come to learn that Apple has hired him, and he is off the board. Unfortunately, I was hoping that maybe there would be potential for us to collaborate with him in moving forward. But he is, it's weird because being in the open source community for so long and knowing the culture in that space, when you start moving over to more of these closed source systems, not that Swift is closed source, but Swift UI most certainly is. The communities are a bit different, and it feels like there's less community-driven efforts, or at least less cohesion in the community than exists in more of these truly open source spaces. So finding these, lack of a better term, thought leaders is a bit more tricky. Finding people that are real experts in a particular technology in that proprietary stack is very difficult because, as we just saw with Max, Apple will go out and hire them pretty quickly. So all that to say, he was a really good resource for us to lean on when we had some questions as to certain behaviors within Swift UI that we really didn't have any insight to, because he was in, I have to make sure I'm using all past tense terms now. He was building a reverse engineered Swift UI implementation in WebAssembly. And so through his own experimentation, he found where a lot of these bodies are buried and probably intuited his way towards how certain things should be done, or where potentially not so private APIs, but not documented APIs existed. Not to say that we're using those, just that he was able to say definitively that using Codable was not the direct way to go. We should be doing what was essentially what the LiveView JS client was already doing, was reproducing a DOM, walking it, and then merging those into the actual documents, the browser's active document DOM. So LiveView Native will first make a dead view rendered connection to the endpoint, get the raw HTML. It'll parse out the LiveView fragment. It will then establish a new Phoenix channels connection as a LiveView connection to that endpoint. And then we'll start getting the diffs over the WebSocket connection and properly merging these into that fragment. And so that fragment, mutates over time. And every time we finish merging into the fragment, we walk it, and then we build up a new Swift UI view tree based upon just a simple naming convention that whatever the element name is, it should be able to one-to-one parity over to a Swift UI component name. So for example, like lowercase text as an element name, we expect it to correspond to the capital T text Swift UI component name. There's a lot of work we need to do in terms of supporting many of the other components out of the box in Swift UI, and then getting all the events in place. But what became apparent very quickly was that this was going to work. I wrote out the original Morph DOM and LiveView client rebuilds in Swift. I did them in a very functional programming way, so very uninformed, very unidiomatic Swift style. but it was extremely performant. I showed Chris a demo over a year and a half ago now, last spring, not this past spring, the spring of 2021. That was 1 millisecond updates over network. We were rendering, this is the demo I showed for Elixir, but just rendering out a incrementing counter that was giving real native UI elements in the simulator. And it didn't show any signs of back pressure, like looking at the memory, looking at the CPU, like nothing was starting to tick up. It was extremely performant, which makes sense. It's a compiled runtime, and so it should be fast. And that's part of the value you're getting in the Swift world, being such a strongly typed language, is that it can impose all these optimizations that ensure speed, but also that when you are compiling, that the application should work as intended. So we spent some time. I don't have the time or inclination to go and be Mr. Swift. So we spent some time and found an engineer, Anil, who joined the project. I believe maybe, I forget exactly when, but maybe earlier this year, maybe late last year. And he's a student, so he was giving us the time that he could, around 10 hours a week, and starting to poke around and push things forward. And then the summer, he was able to commit to, I believe, 30 to 35 hours a week, and start to really accelerate the project. And we were really building towards ElixirConf. We wanted to be able to show and give people code that day. I don't think I did a good job setting expectations, in the sense that I forgot to mention that this is very, very early and that we are now in a refactor period. So one of the first things we're doing, and I have a call later on today, and I published a blog post about this earlier today on Dockyard's blog discussing this, is we're going to extract out the common code amongst what the two clients we have started already, which is the SwiftUI client and the Jetpack Compose client. That being the morph DOM, like real function of, or re-implementation of essentially taking these diffs and being able to patch them into a DOM-like representation. And then there's probably going to be other ways that we can extract it out. So we're going to do this in either C or Rust. We'll have a common library that we can then share. I had a bunch of people at the conference. It may just be the excitement of the conference, but people are wanting to build. And I'm very interested in having a Windows UI 3 client. I know someone was very interested in the Unity client that I suggested might be a cool experiment. And pretty much anywhere there is a native screen and you can establish a socket connection, it's a potential application for LiveView now. We have a lot of work to do to make that an easier experience for new people to build clients. But that's why we're taking this, instead of continuing to put our heads down, just work on the Swift client, we want to establish kind of this ecosystem of clients from the get-go. We want to make sure that we're providing essentially a head start for anyone wanting to build a new client. So the goals after that are going to be, I think, in many ways, taking things out of the existing SwiftUI client. There are things in there, like we have this form component that acts and behaves very much like a web form, meaning that any of the input element types that are children of the form, if you use a submit button that is a child of the form or associated with the form, it will serialize the data in all those inputs and submit it. Well, I shouldn't use the word submit. It's just the function in LiveView that sends the data. This is not a SwiftUI form. And so I'm very dedicated towards a couple goals for these projects, which is first and foremost, we only cover what is out of the box with the target UI framework. And in many cases, we may be covering components that don't necessarily make sense to be used in isolation like this, but we're covering those components still because we have a system built into LiveView Native that allows us to build custom components and import them in and expose them to LiveView. So that form I just spoke of will probably be broken out into its own library, just called SwiftUI client form or something like that. And now that will be built upon, it will depend upon LiveView Native being there, but it will provide that web-like form functionality, which is going to be really important for building out any real forms on LiveView Native, because in SwiftUI, you have the programmatic side where you can identify the specific inputs. Like you hit a button to submit data, you can say, I want the data from these individual inputs, and you can build that post body essentially from it. Or you can send it over the wire, you can serialize data however you'd like, which we're not going to be able to do with LiveView. So we need to provide some functions to do this. However, I want to keep the kind of base library as tied to the default implementations as possible. And this allows us to hopefully do less work. We're not going to be reproducing documentation that already exists on the SwiftUI framework site. We're not going to be reproducing documentation that already exists on the Jetpack Compose website. So what we would hope for is that if you need a component, you can go to those individual UI framework sites, find the component, and based upon our conventions, you should be able to quickly say, okay, it's called this in SwiftUI. We just rename it. It's a camel-cased word. Now it's a hyphenated lowercase element name. And here are the modifiers that it works with. Okay, we know how to use the modifiers. So that's kind of the approach that we're taking here, which should allow us to spend less time having to reproduce something that's already been built. So at the end of the day, LiveView Native will hopefully, the breadth and scope of it is going to be large, because we can not just build iOS applications in the SwiftUI world. Apple wants to use it everywhere. So we should be able to target and deploy to iOS, to macOS as a native desktop application, not just as the M1 wrapper for iOS apps. We should be able to build tvOS applications. We should be able to build watchOS applications and any other future devices that Apple produces that is going to permit SwiftUI applications to be built on them. Now, if you take that vertical of device type targets in the SwiftUI ecosystem and you go horizontal across, the same thing would apply to Android. Jetpack Compose is a much younger framework than SwiftUI, even though SwiftUI in itself is pretty young. So I believe that Jetpack Compose is not yet targeting all of the all the Android compatible devices. I probably have to familiarize myself a bit more with Jetpack Compose, but that's my understanding, is that there are less current deploy targets, but the intent is there to add more deploy targets in the future. So, in the Android ecosystem, we can start targeting Android TVs, we can start targeting the Android Watch, and so on. On Windows side of things, I don't know if anyone has a Windows phone anymore, if that still exists, but if it even used if it used WinUI in any way, if they're updating it, probably not. But the Windows as a environment on desktop is still incredibly popular, especially outside the United States in many countries. So there's going to be a lot of potential in terms of where LiveView as a programming model can be used. And then after that, it's really just a matter of understanding and having some understanding around the build systems for each of these native environments. And, in Apple land, you have provisioning. So we're not trying to reproduce the IDE. We're not going to say, hey, these are tools that you can do with Mix and like produce some sort of, binary asset that you can use this other service to get on. I remember all that stuff with PhoneGap and Cordova. They went like way overboard. They had this whole like online build system, and it was just constantly behind the ball. Like Apple would change something and then they would be like a few months behind in getting up to speed. I'm just punting on that idea right from the get-go. I'd rather just say, hey, you know what? You have to accept at some point you're going to have to open up Xcode if you want to do this. But we're going to keep a majority of the work inside the LiveView side of things. And the other design decision that we made is that we don't want to be the entire application. LiveView Native being mixed into the composable view tree of a SwiftUI application is just another view component. So if you wanted to, you can have LiveView sit inside a more complex, and natively built Swift UI application. If you have an existing Swift UI application and you need to have some sort of if there's a need to just bring the LiveView native component, you can do that. The thing that I don't know that we have to test, I mean, it wasn't in scope, but LiveView as a framework allows you to have multiple live views active on the page at once. I'm not sure if we support that out of the box at the moment, but I definitely do want to put it in scope. Basically, how you're building LiveView web applications should mean that you can bring all that over very quickly to build up LiveView native applications. Our goal, our target audience for this is a junior engineer should be effective in building native applications with LiveView native. If we're finding that it's taking senior engineers or like well-educated like mid-levels, then we've missed that goal, and I feel like it's going to significantly hurt adoption. So I see Brooklyn nodding his head. Brooklyn is heading up our academy efforts, and I will be hitting him up at some point to start beta testing what we're doing with juniors. So L, you saying this is you? Okay, L has a question.
I don't remember us covering this in the keynote. Because we make the XML very specific to each thing, we currently don't have any guidance for like you're both doing a iOS and an Android app. So it's like kind of up to the users to determine how to do device detection and how to select the devices in view, correct?
So I asked Eric, the creator of Hex, months and months ago, if we can just swap the Phoenix LiveView native package name. I think it's just LiveView native package name. And so we have it set aside. We need to release something. If you were to look at the chat application, so if you go to github.com/LiveView native, and I think it's called ElixirConf chat, I forget the repo name, but there is code in there, and I linked to it from my blog post that shows how to do the drop-in to very quickly do platform-specific template rendering. So right now, the clients will, at connection negotiation, send over their platform information. But there's a much bigger, that is kind of a very naive approach to it. Because even though, yes, we connect, it's an iOS device. Okay, which iOS device? Are you in landscape mode? Are you in portrait mode? Are you in, how much screen size do you have? These are all things that we're going to have to figure out. And I know that React Native has some something to say here. There's an open issue on this. I opened it up a few weeks ago when I started thinking about it. And after, or maybe during the conference, someone weighed in on it and noted that there is pre-existing work in the React Native space that at the very least may give us guidance on the scope of what we should cover and what data we want to be sending over. But we need to be able to pattern match on that twice. We should be able to pattern match on like the mount functions and the update functions, and then we should be able to pattern match on the template rendering. We just have to figure out what is going to be a reasonable way to do this that doesn't quickly get out of control, because we don't want templates called like lobby.ios .portrait screen size .heeks. That's going to be like stupid. So it may be a combination of things where in the template itself, if you move between portrait to landscape mode, maybe there's a conditional that then re-renders for specific. Now you have more screen real estate and you get this other thing instead. That could be a solution. We just haven't really talked our way through it yet. But yes, El, to your point, right now, out of the box, it all renders off of the same HTML.geeks file. But if you, if you go to that example repo, and if you look at my blog post, I link directly to the file that will extract out the platform key and then apply it on all the render requests over LiveView in order to give you platform specific templates. So I think right now it's just like LiveView controller name dot platform name dot heeks, and it will default to .html if there is no platform information.
If I'm recalling correctly from the Slack channel also, we do for Swift support the constraint system that you'd use in the UI builder in Xcode. So we kind of have responsive support already because Swift UI just works that way, right?
Yeah, we don't have any examples to show, but it should be fine. And this is actually an area that I'm starting to wonder, like, how much do we lean into on device versus kick it off to server? So another example of this, there's an open issue right now around, I guess there's a Lang component in Swift UI that allows you to manage essentially internationalization. So you can, I don't know if it does like on-device translations or if you're having to provide the translation file and here's like the key as we're used to on the web. But my inclination, I mean, we should probably support it just because we want to cover the entire API surface. But my inclination is that because we're building LiveView native applications, if we're already doing internationalization on the web, we should just repurpose that for LiveView native and use the exact same rendering conventions that we do in template, where we provide the language file and we are outputting either default or your specific country code's language values for this particular key. And then you can simply have, if you switch between languages, that's simply an event to re-render the template from server side. So I think I would expect to see more of this, where more traditional, like people with more experience building Swift applications may say, oh, we already have this function that exists on Swift. Why don't we just do this? But to me, that feels like we're asking people to implement something in two different ways. And if we are saying that LiveView as a programming model has value and it works on native, then why not just go all the way and just say, we're going to be sticking to trying to keep people in the LiveView side of the development as much as possible. And there will certainly be really good cases on when it doesn't make sense. Like we don't want to find ourselves in a place where we're constantly just fanboying on LiveView and say, LiveView, LiveView, LiveView. That opens us up to very, very valid criticism that you can't use it here. And then the rest of your arguments are invalid because on the internet, everything's binary. So you can't be wrong about one thing without, or you can't be right about one thing and being wrong about the other thing. The point is that we need to be nuanced in our approach, but also communicate and be careful how we communicate when LiveView makes sense to use. But also, I think along with Chris's desire to grow its utility on the web, we could probably have opportunities to do that on native as well. So to that point, not that we have much of direction on this in the moment, but Tom, who is working on the Jetpack Compose client, a few weeks ago, he messaged me. He goes, hey, check this out. So I jump on to a call, and he had implemented the Canvas component on Jetpack Compose. And he was actually showing how he could have objects move around screen in a game-like fashion with LiveView Native. Now, whether or not this makes, like, just because you can do something doesn't mean you should do something, but it opens up potential to use LiveView Native outside of the, I'd say, like the productivity app scope that I originally envisioned. In addition to that, there is, I just found this a few days ago. There's actually I think it's called like Swift UI Charts. It's in beta right now. It's a whole suite of data visualization components that are being built by Apple. And this would be an amazing thing for us to wrap. But we need to get all of the like standard components out of Swift UI done first. And then we can build out a separate library on top of that, the charts library that brings in all the Apple data visualization charts out of that. And that was something that I knew that, people even asked about it at the conference. Can we maybe do a D3 type thing or something like that? And I was like, anytime, the whole point is to not do JavaScript, and people are asking about web views, and I don't want to say no to things, but at the same time, I think I'll be pretty careful to punt on official support for. Like if there is a web view component in Swift UI, which I don't think there is, but if there was, we would still wrap it. We just would not really support it beyond that. it'd really be, it's up to you at that point. If you really want to go that way, Swift does provide this interface for taking JavaScript and having it produce Swift UI, produce Swift code through the interface, and vice versa. So you actually, maybe it's one way from the Swift code to the JavaScript. Maybe it's not back and forth. I forget actually, because I really did not spend much time looking into it because I knew right away that this is not what I wanted to do. But all that to say is that we're going to try to keep this library as simple as possible. And if you want to extend it into a direction that we didn't intend, have at it. We're not going to, give you very hard guardrails on it, but also be aware that, there be dragons where you're going. Looks like Matt's saying that the link on
just the hex and GitHubs and everything will be in the published YouTube about section.
So one thing I found out last night, I realized last night when I was writing my the blog post for this. In my blog post, I meant I'm going to try to write weekly updates on the project. But anyway, the HEEX file type stands for HTML EEX. And I guess that makes sense. I just didn't think about it before. But, in the context of LiveView Native, we're not going to change it because that's what it is. But it's just this kind of artifact of the naming that it may exist. And sure, some people say, why is it HEEX? It should be NEEX. But yeah, it's not going to matter. It'll still provide the same value. Brooklyn has his hand up.
Yeah, I would love to just understand a bit about what the developer experience is going to be like. So I haven't been involved in this project at all, so I kind of get to be our resident, hey, I don't know what's going on, and I can ask the simple questions. So if I want to get involved in this, if I'm like, oh, hey, LiveView Native, that sounds super interesting and exciting, how can I get started? What's that going to look like for me?
So for now, it might just be worth going through the tutorial, which is if you go to the LiveView Native org on GitHub and you go to the Swift UI client, there is a link in the README to the tutorial. And this will step you through building out, I think there's 2 sections to it. So the first section is about building out a fairly rudimentary, but at least somewhat feature comprehensive native application where you get to not just render text, but render images asynchronously, implement navigation, and have some interaction with the page. There's like a review system where you give something a star rating, or you just start once and it will resort and keep your starred items at the top. So I think that's probably a good walkthrough of what we're hoping the developer experience will lead towards. And honestly, the refactoring that we're going to end up doing may be mostly transparent for like the API that's being exposed in this tutorial, because many of those component names are going to stay the same. We've already implemented some of the modifiers to be used as attribute key value pairs in the template. But I think async image, I'd have to take a look. I think async image is not a standard Swift UI component. And so that would probably be extracted out into its own dependency at some point. I think everything else in there would be standard. But we only have about 1 or 2 of the Phoenix LiveView bindings implemented right now, and they're really hard coded into the components in question, like button components. So we need to be extracting these out into a more common event system that will that should be able to apply these just based upon them being present. We don't want to have to go through on every single component and re-implement every single binding again and again. And I think, too, there's going to be a need to, if not set up binding aliases, to rename some of the bindings. So on mobile, for example, there is no concept of click, right? We have a concept of touch. And we see this on JavaScript frameworks. I think even like jQuery, I know they have implemented like the touch events. I don't know if they have sunset the click events. Like they started out as click events, but now I think everything's kind of moving over towards touch. Anyway, all that to say that on LiveView Original, LiveView Web, we wouldn't ask for any change of binding names, just that we are going to introduce new bindings that will essentially be the same. We just want to be idiomatic for the device that we're on. So like phx-click should be identical in function to phx-touch. And wherever there are touch interface specific name changes, that may be the direction that we go in. But yeah, I think the tutorial, Brooklyn, is the best place to start. We need to start, soliciting feedback. We need to start getting some ideas. We'll probably in the next few weeks start to have an open, like not necessarily a core team. I don't want to start declaring core team yet, but I do want to start having open meetings that people can join and weigh in. And there's going to be a lot of things that I say no to. We're not going to take on everyone's idea. We're not going to expand the scope of this beyond something that is, that becomes difficult to manage and maintain and becomes difficult to educate about. And one area that we're certainly going to need a lot of help in is the education side of it. We're going to need, when we get to the point of documentation, tutorials. The tutorial for the Swift client is great. This is something that I guess is generated automatically by the Swift library docc, I think it's called, or DOOC, I forget. But it gives you this really nice web-based tutorial that has cool things in there, like it looks like an Apple website. Essentially, it has that kind of style to it, and it will allow you to embed in video to show, like, if you make this change, here's how it should look in the simulator at this point, which is kind of cool. That's really kind of a question that we have moving forward too, is where do we lean into those device-specific ecosystems? Should we be producing documentation and tutorials for each of the individual devices that are common and feel like they're part of the Jetpack Compose ecosystem, or feel like they're part of the SwiftUI ecosystem? Or should we pull it all back and just say, you know what, these are going to be more like HexDoc style tutorials, where someone that's coming from the Phoenix side of things is familiar and like knows where to find them and what to do with them. I don't know yet. These are all good questions and areas that we need to figure out over the next few weeks and few months.
I have more simple questions.
Sure.
If you don't mind me pestering you with simple questions.
Go ahead.
So I'm really curious to know, are my Phoenix app and my LiveView Native app, are those separate, or are they now together within the same project? Like, is this something I'm adding to
the chat? Yeah, the chat application it's a Phoenix generated app, and I believe that the native app lives in the priv directory. I would recommend against doing that, only because we found on building out client-side applications, it was always best to separate the two. You get a more clean version history, like you get just easier overall. And also, if you think about it, like if we're at the point where we're supporting 3 different native clients, whether it's Jetpack Compose, Windows, and Swift, if you have multiple devices per client, I mean, it just may make more sense to keep those in separate repositories. There's no reason that it'd really be up to the team doing it. But for my money, I think it's cleanest to break those out into their own repos.
We're at about 45 minutes. Sorry, go ahead.
Yeah, I was just say I like simple questions.
Good for the newbies here, like myself included. So fire away with those.
Yeah, I have.
What about concerns about approval from the App Store? I know.
Yeah. So we don't know for certain, and that's a legitimate ask. What we do know is that we've submitted 2 applications with LiveView Native to the App Store, and both of them have been approved. We also know that there are other existing works in the App Store that are doing server-side rendering for UI rendering that mostly rely upon WebView type stuff. So this is, in some ways, what we're doing is unique, but it's also, it seems like there are analogous efforts at some level. One thing I know that would not fly with Apple is remote code execution. So we are staying very far away from that. The JS commands, part of LiveView, to me, feel like it's really encroaching on remote code execution. So we're gonna have to figure out some way to implement the behavior of that without violating that agreement. In my mind right now, it would be some sort of event system that you can, maybe there'll be some default events beyond the Phoenix bindings that you can bring into your native application, and then you just call it with the commands, be like native.command or something like that, or native.event. Just send the event name over the wire, and then our client would be listening for it, and then the event could come with arguments or parameters or something. But there's been nothing done on that front just yet. I just know that we're not going to ever attempt to do remote code execution. It seems like on the Google side of things, they just don't care. And so I think we got Google Play approval before we got App Store approval. And we never even submitted an app for Google Play. We just opened it and they said, yeah, you're good to start pushing. And I don't know. It seems like it's a more like Wild West type playground over there.
I see on the App Store for Android, sometimes it's like verified by Play Protect. So maybe there's like an extra level that you can go through, but I'm not sure how that works.
Yeah, I'm not sure either. I'm educating myself as I go in this space.
Well, it's kind of like Chrome extensions. I mean, basically anybody can kind of publish one. And then if they get in trouble, they get in trouble and get pulled.
Yeah. I mean, that's one way to deal with it. It's either an upfront cost or an after the fact cost. And Apple's absorbing that cost up front to protect their users, and Google's punting on that cost potentially, to make it, you gain, you lose something. There's always a trade-off in technology. Go ahead, Brooklyn.
I have another straightforward question, which is I'm curious about how this works for supporting multiple different screen. Like if I'm doing iOS or if I'm doing Android, am I writing in one ubiquitous language, one templating language? Am I always creating 2 separate templates?
We don't know that yet.
Have the options. Okay.
So I mean, between Android and iOS, then yeah, we would want you to write in 2 separate templates, because the UI element names, component names, are going to be different between Jetpack Compose and SwiftUI. When it comes between the micro targets in those frameworks, so you're targeting Mac OS, or let's say let's go like WatchOS to Mac OS. So presumably there are going to be certain components that don't make sense to use on WatchOS or don't work at all. And you clearly want to provide an experience that's specific to that device. And so in that way, we will need some way to pare that down. And so part of the platform negotiations likely to include the device name. This is we'd say like this is a SwiftUI device, and then like the template name may be more like lobby.swiftui.watchos.heeks, something like that. Ultimately, I think that level of differentiation is probably as deep as we want to go. And then inside, say, the iOS, I'm not sure if we want to differentiate between phone and like iPad, but let's imagine for a moment that we're not. So it would be like lobby.swiftui.ios.heeks. And inside there, you may have conditional statements that you can then like say when, again, like it's landscape mode or portrait mode, or if it's on iPad versus iPhone, or if it's, maybe we can even go as deep as specific iOS versions. I really don't know what makes sense for us to go down to just yet. But I do know that the more complex, I'd say the more enterprisey applications want that degree of control. And so we need to find a way to provide it, but not have the application development experience feel like it's like I have like 20 templates for just one LiveView controller. There should be almost like an opt-into system where you have like some basic common sense differentiators between templates, and now you can opt into higher degrees of fidelity if you want to.
So I'm curious because I know we want more feedback from the community. We want to get people's opinions on this. How can people get involved in that? Like, what's the best way to share their ideas? Should they be raising issues? Is there
the GitHub issues tracker right now is where we're just asking people to put ideas, and we try to comment on them. We have to be careful. It's such an early stage of this that not to say we can't go backwards, but when you kind of commit to an idea, there's a lot of, it's easy to say, to propose an idea, and it's very difficult to see that idea through. And so there's going to be times when we say no, and we'll try to best to explain why. And this may not align with your expectations on what you would want LiveView Native to be. That's fine. That's not, we're not trying to make everybody happy with the base library. We hope to address your concerns and needs with additional libraries that will be built on top of the SwiftUI client. But the SwiftUI client itself, its design goal is to be as pared down and simple as possible, but in a way that allows us to cover the breadth of component APIs that exist in SwiftUI itself. So it's a comprehensive yet hopefully slim package that ultimately will be produced. But yeah, the contributing to the GitHub issues would be best. I see now it's 2:30. I think I have another call I need to jump onto, which is the LiveView Native demo. So I'll end the roundtable here at this point. So for people that are curious, I'll just sum up. We are actively developing, and we are also looking to hire a lead SwiftUI engineer right now. Our current SwiftUI engineer, he's back at school, so his time is limited. He's limited to 10 hours per week. So, if you use some simple math, it'll take 4 times as long for him to implement something in a given week than otherwise, which we want to, I want to recognize the opportunity costs here. And we want to get somebody that can build on top of what he's already done, but also work alongside him and continue to push this library forward. Our focus at the moment is really shoring up the SwiftUI client. And then we're going to take some of those learnings and teachings and essentially build up a way to communicate how these clients should be built. And our first test case of that will be the Jetpack Compose client. So anybody has any other questions, you can, not in here, but outside of here, if you want to hit me up on Twitter, I'm happy to answer. Also, if there are any companies out there that find this technology cool and want to help sponsor it, we are totally open to that. We are not looking at this to be a solo dockyard effort. There's good opportunity to get your company's name attached to this project early on.